So there are two ways that we can derive the formula for a regular hexagon in terms of its side length. One of them uses trig, and one of them uses radicals. Okay, so I would advise that you do whichever one you think you would be able to understand the best, even though the answer will be the same no matter pretty much which way you do it. So let's do my best to draw a nice regular hexagon. Okay, regular means it has all equal sides and all equal angles. So all of these are the same. And all of our angles, of course, are 120, if you are familiar with that from pentagons or from hexagons. It has an interior angle sum of 720, so every angle is 120. So we have one variable, and I'm going to call it S for side length. Okay, so we want to write the area formula with just the side length. Okay, so one way, let's start over here. So the area formula for any regular polygon is 1/2 of the apothem times the perimeter. Okay, that formula can be found just about anywhere in a geometry textbook, many online forums and what have you. Okay, A stands for apothem. Okay, hopefully you're familiar with what the apothem is, or the apothem if you are so inclined. That is the length of the line from the center of the polygon perpendicular to any side. That is your apothem. Okay, N stands for the number of sides, hashtag sides, and S is the side length. So in other words, we don't want to have an A in our equation, nor do we want to have an N. We only want to have an equation with just S, the side length. Okay, which isn't bad. We know N, how many sides does a hexagon have, is 6. But we have to figure out something to do with this apothem. Okay, so this is the hardest part here, is trying to figure out a way to substitute in for the apothem. Okay, now one way is using trig. So we can draw in the second thing, which would be a radius here. Okay, where this length right here, now we have a nice right triangle, where this is 1/2 of the side length, and this angle can be found by doing 360 over 2 times 6, okay, which hopefully you know is going to be 30 degrees. Okay, so it's 1/2 of a central angle of a hexagon. So I can set up this trig ratio using the tangent, because this is the opposite side and the apothem is the adjacent side. So the tangent of 30 is equal to 1/2 of the side length divided by the apothem. Okay, now remember over here, I want to get rid of A, or replace A rather, which means I have to solve for A over here. Okay, so we always multiply by the denominator, which moves the A to this side, and then I'm going to divide both sides by the tangent of 30, and find that the apothem is 1/2 of, or 1/2, okay, times, so we're dividing also by the tangent of 30, times the side length. Okay, so that is how the apothem can be found if you know the side length, is by taking that side length and dividing it by 2 times the tangent of 30. So I'm going to take this fabulous thing, and I'm going to replace it over here. Okay, a little bit of substitution. So that would be S over 2 tan of 30. That is now my A value. So everything else stays the same. There's my 1/2. There's my times 6. There's my times S. All that wunderbar stuff. So now I simply have to simplify. That's what I simply have to do. So make them all into fractions. And when we have fraction times a fraction, I always multiply numerators times each other. So all that stuff times together is 6s squareds. And I multiply all my denominator stuff together. When I multiply all that together, I get 4 tans of 30. okay, which is a pretty good equation, only I know, maybe you do too, that I can simplify 6/4. I can simplify 6/4 to be 3s squared divided by 2 tans of 30. Okay, so if I just knew the side length, I would be able to figure out what the area of this hexagon is by using that formula, okay, using a trig thing. But that's not the only way. So let's come back over here. Start again with 1/2 of a times n times s. Okay, replace our n with 6. And let's talk about the other way. Okay, so in addition to this being a tangent relationship, that triangle that we drew in our hexagon, remember our hexagon looked like this, is also a 30, 60, 90. 30, 60, 90 triangle, where the side length of a hexagon is the same as the radius. So if this is the hypotenuse s, then the short leg, of course, is half of s, like we talked about before. But then the apothem length here is the short leg times the square root of 3. Okay, in other words, s roots of 3 divided by 2. Half of the side length times the square root of 3. So rather than apothem over here, I'm going to have s roots of 3 over 2. Okay, so that's the other way that the apothem relates to the side length, only for hexagons, because hexagons are the only thing that have 30, 60, 90 triangles in their apothems. Okay, so once again simplifying, I do all of my numerator stuff, 6s squared roots of 3, all of my denominator stuff, 2 times 2 is 4, and then I still have to simplify my, or rather reduce my 6/4 to 3s squared roots of 3 divided by 2. So there are 2 formulas that we can use to express the area of a regular hexagon in terms of just its side length. Go back.